Look at the trend of atomic radius when looking at the periodic table. So if you compare two elements of the same group, for example, magnesium and calcium, you note that magnesium has 12 protons in the nucleus, and it has 2 electrons in the first energy level, 8 electrons in the second energy level. That means there's 10 core electrons and 2 more in the third energy level. So that means that its effective nuclear charge, 12 protons minus 10 core electrons that shield the nucleus from the 2 electrons. You have an effective nuclear charge of 2 plus for magnesium. When you look at calcium, 20 protons, and they have n equals 1, n equals 2, n equals 3, and n equals 4 energy levels. So the effective nuclear charge here is 20 minus 18 equals plus 2. So the effective nuclear charge for the electrons in the outer shell is the same. However, for calcium you have 1, 2, 3, 4 energy levels, where in magnesium you have 1, 2, 3 energy levels. And as the energy increases for the energy levels, the larger the atomic radius. So as you go down in the periodic table, the atomic radius increases. Let's take a look at the trend going left to right and right to left on the periodic table. So if we take sodium and chlorine, for example, both are of the same energy level. However, let's look at the effective nuclear charge. So for sodium, it has 11 protons and 2 energy levels, and a third with 1 electron, giving it an effective nuclear charge of 11 protons minus 10 shielding electrons, an effective nuclear charge of 1 to this electron here. When comparing chlorine, chlorine has 17 protons, 2 electrons in the first, 8 electrons in the second, and 7 electrons in the third energy. So its effective nuclear charge is 17 minus 10 gives you a plus 7. That means that there's an effective nuclear charge on electrons on the outside. So there is a higher attraction for the electrons on the outside to the nucleus versus that of sodium. So because the electrons are held tighter, then the radius of chlorine is much smaller than that of sodium. Trend is if you go to the left, the atomic radius